Hello, and welcome to a Learning to CAD just by looking at it style tutorial. So today I'm going to be looking at 254's collector, as is probably not surprising since they just recently have gone undefeated for the season. Looking at other teams' robots, figuring out how they did it is very helpful for both learning how to CAD other things we see in future years and also learning the design of things for the current year. So this is sort of inspired by this picture that Charles had posted. And if we look at this picture and zoomed in here, we can really zoom in on the collector for 254. And so one of the things that we know from videos is that this collector is a little bit different than these other three. So these other three collectors are also California teams that do relatively well. But 254's does something a little different. Its collector also rotates into its own body. And so one of the things that we want to do when we decide to CAD and figure out how it's put together is we need to watch some videos, know sort of what it looks like already, which I've already done, and I'll show a little bit of one video during this as well. But for this, we're going to take a look at the image, see if we can break down the systems, and see if we can figure out how they made this all happen. So during this video, I'm going to be doing some CAD as well as going back and forth between different websites like VexPro and AndyMark to find CAD files. And feel free to either follow along and do CAD with me, pausing when you need to catch up. Also, feel free to just watch it through once and then go back a second time once you know sort of what's coming and go ahead and follow along with the CAD. All right, well, let's get started. Okay, the first thing to keep in mind here is that a cube is going to fit right in here. And so what we're going to do is we're going to break this down into its composite parts. So we're going to start with this part here, just more or less the gantry. If you look, this has some stuff up here as well to assist with raising and lowering it up the elevator. We're just going to worry about this part that connects to the main collector. So we've got the gantry part here, then we've got the Ford collector part here, and then we've got the arms that actually do the collecting themselves. But let's go ahead and start with the gantry. So the gantry width, this interior portion, is probably going to be at least 13 inches and probably a little bit wider. So if we subtract one, this looks like a 1x2. And this looks like probably a 1x2 as well, and I sort of confirmed that by looking at some of the videos of this moving around. And so let's go ahead and start CADing this with the assumption that, let's say this is 14 inches across here, so a little extra room. And we can go ahead and go into SolidWorks and get started. So we're going to start with a new part. Open that up. And we're going to start with a new sketch. I like the top plane. I don't know if it actually matters which one you pick, but that's the one I usually pick. So go ahead and pick a center rectangle. And we're going to just drag out the center rectangle. Now, for me, if I hold down right click and scroll up, it automatically goes to Smart Dimension. So I'm going to dimension this. Like I said, so we're going to make this 16 inches because 14 inches of it are going to be the interior portion. We're going to have a 1x2 tube on either side, cutting off an inch from each side. This is a 1x2 tube, so we're going to go ahead and make it 2 inches, and then we're going to go ahead and extrude this, finish the sketch, extrude it, and it's going to be 1 inch. Now, we can go ahead and make this so that it's actually like the 1x2 tube that they use. We can do that pretty simply by clicking on one of the faces that we want to shell out, click the shell. So typically for the tubing that we buy, it's 0.125 inches, but I know that they're able to buy smaller tubing, and we'll go ahead and reflect that to 0.09 thickness. And then we'll also decide to make sure it does the whole thing, clicking on the second face here, click OK, and sure enough, that looks great. So now, if we go back to the picture, we're going to add in these side arms. So I'm going to go ahead and estimate that they look about as long as this is total wide. So I said that was 16 inches, so we'll go ahead and make them 16 inches. So one thing to keep in mind while we're doing this is that it looks like this arm when this arm folds in on itself, it's going to have to do something a little funky. And I'll get to that while I'm drawing out this sketch here. Okay, so we're going to start a new sketch on this face. So I'm going to go ahead and click Sketch. This time we're going to draw it out with a line sketch versus with a square. I'm going to square us up, and we're going to go ahead and say, all right, let's go ahead and start from the bottom here and go over. And we can dimension this all in a bit. Then we're going to go up, and we're going to want that to be 1 inch, but we'll figure that out later. Do another line. This one's going to go up 2 inches. I was wrong about this. This does want to be up 2 inches or so. And then we're going to do the little interesting thing that I was talking about. So for this to actually function where it can fold over on itself, it's going to need to have a little bit of extra space here. So I'm adding in some lines. We'll get those guys even. Then I'm going to add in a tangent arc so that I have a good spot to put my bearing hole. So it looks like on this, if I look at it, that there is a bearing here that is going to need to be allowing for motion and allowing for a motor and chain to power it. So I'm going to go ahead and put in a bearing hole. Typical, I'm going to go with the 1.125 inch hole. May or may not be the exact hole size that they're using. If I look at this, that looks like it might be actually a little bigger than that, but I'm going to give it a shot. At this point, what we're really trying to do is just do what they did, or approximate the mechanism that they did, not do an exact duplication. All right, so we're going to dimension some of this stuff now. So we say, all right, this is going to be 16 inches. Oh, look at that go. All right, we're going to say, let's say this is 1 inch up. And I think then we just need to dimension from here to here. And that did not do what I wanted. Let's try that one more time. There we go. We'll make that 2 inches. All right. I'd say that looks pretty reasonable. So I think from here we can go ahead and get this guy, which we're still missing. 2 inches. All right, so now we're fully defined. Down here it says fully defined. What that means is I don't need to add any more dimensioning. It knows exactly how this is all going to be. So let's go ahead and exit out of our sketch, and then we're going to do another extrusion. I'm going to rotate this. We want to go the other direction, and we're going to go 1 inch. Then we're going to do something a little bit funky. We're going to re-select that sketch and do a second extrusion. This time we're going to offset it. We're going to offset it the length of this main piece here, 16 inches, and do 1 inch again. And so now, anytime I change this sketch, it'll change both of these extrusions. So everything ends up being symmetric all the time. All right, so now we have our first part. And if we go ahead and look at the picture again here, that's pretty much all that we need it to be at this point. So I'm going to go ahead and save that. So we're going to save this, and I'm going to put it in my First Robotics 254 collector, and we're going to call this 254 gantry. All right. So now that we've got this, let's take another look at the picture. So we're going to choose a second piece to attach to it. So let's go ahead and make this piece then, piece that attaches to it. So it looks like it attaches to it over here with just the general bearing. And over here, it's got a sprocket with a chain on it. If I'm going to estimate this distance, it looks like this is 1 inch, and it looks like that's 1 inch to me. Now, 254 typically uses 1/4 inch plate, which is what I'm assuming this is right here. And then this looks to be 2 inch by 2 inch box tubing. So I can basically use this outer diameter, which is 16 inches, to decide the inner diameter here, and which also decides the main distance of my 2x2. So let's go ahead, start a new part, and we're going to do another sketch. So we're going to start off again, the center rectangle, we're gonna say, all right, so now let's do a little math here. So if we want this to be 1 inch out, 1 1/4 inches out on either side, that means we have to add 2.5 inches to our 16. So we're gonna say 18.5 inches. And it's a 2 by 2, so we'll make this guy 2. And then we'll go ahead and extrude it 2 inches because it's a 2 by 2. And we'll go ahead and shell it out. So we'll shell it. We'll do 0.09 again. And we'll do the second face. So it goes all the way through. All right. Boom. Done. Now we need to add on these side walls. So what distance they look? Well, that's 2 inches. Maybe they're 4 inches out, and they probably have that rounded edge as well. So we'll go out 3 inches, and then we'll put in our bearing hole. So the way we're going to do that is very similar to how I did in the last one. I'm going to select this face here, and I'm going to go ahead and sketch on it. I'm going to sketch with my line tool. I'm going to go up 2 inches. I'm going to go out some distance. I'm going to go down and basically make a square here with this. I'm going to go ahead and select here and make it construction because I don't need it for the actual extrusion, and use this tangent edge again. Make a circle here. Dimension it 1 1/4 or 1 1/8. And there we go. We're ready to extrude. Go ahead and extrude it. Once again, we're going to switch the direction. This time it's only 1/4 inch. And then we're going to do that same thing we did last time where we reselect the sketch. Sorry, not edit. Reselect the sketch, extrude it, do an offset. This time it's going to be 18.5. The other direction. There we go. That is square to the end, and we're all set. Alright, so we're going to go ahead and save this, and we're going to save it as 254 collector main arm. And then what we're going to do is we're going to go ahead and make an assembly from this part assembly. So we're going to start to assemble the collector. So first we're going to click to insert one of the main collector arms and click to insert the gantry. Then we're going to go ahead and select these internal cylinders, hitting shift in between them, and then mate them. Make sure it's a concentric mate. Click OK. And next, we're going to go ahead and we're going to say we want this plane to be 1 inch away. Clicking distance, 1, then making sure the dimension is in the correct direction, and then leaving the mate menu. So now we're moving here. The problem is the way that we sort of think about it, this gantry doesn't move. And this piece does. So what I'm going to do is I'm going to right click on the gantry and click fix. And I'm going to right click on the main collector and click float. So now it moves more like the way we would expect. And here's where we can start to see this offset and how it becomes important. So if we look at the side, what's going to happen is if we don't have this offset, it's not going to be able to fold flat. Now right now it folds exactly flat. But if we look at the picture, there are things that are above, like this here, and this all these bolt heads basically are going to be a little bit above this 2 by 2 plane. And in fact what it looks like is they have this piece to make sure that it hits here and here, doesn't go too low. Now that being said, what we're going to need to do then is go back to the gantry and go back to the sketch and increase this distance here. So let's go ahead and make that 1.5 inches. So what we're doing is now when we go back to the assembly, we're going to update it, and it moved up now. So now there's this room in there for the things on the main collector arm to actually fit when it's folded. And we can adjust this as we go, but as you can see, that's a great way to change things as you go, just changing the sketches back on the main parts. And that way, since we have the dual extrusion where this one is actually both based on one sketch, everything just sort of updates itself. So let's go ahead and save this assembly, and save everything along with it, rebuild. We'll call this guy 254 collector. Alright, so now we've got the main portion of the body in here and moving. Now let's go ahead and take a look at this picture again, and let's start adding in the things that actually allow it to do that motion. So when we look at the collector, this isn't just going to magically do this. There's something going on at these hinge points that allows it to do this and to do it in a measured fashion. So what we can do is take a look, and it's pretty clear that on this side there's not too much going on. This looks like it's just some metal that's holding it in place as a bearing. Now this side, on the other hand, there's definitely something going on here. What we've got is a sprocket with some chain on it, and that looks to be collinear and concentric with that hinge. In addition, something that we can spot if we look carefully is this looks like a 775 Pro to me. This looks like a motor, and my guess is that this motor is what's handling this hinge. And so what we're going to have to do is basically put in a motor with a gearbox. The reason we're going to need a gearbox in this case is because there's quite a bit of torque going on. It's going to have to lift the cube, which weighs 3 pounds, and all the collector and wheels. So if we think of this as being, about, let's say this is a foot out, maybe a little more, and so its center of mass is going to be, say, 6 inches out, and it's going to be holding, let's say it's 7 pounds. So divide that in half because it's only 6 inches out. If it was 7 pounds a foot out, that'd be 7 foot-pounds. So instead, what we're actually going to know is that, okay, it's halfway out, so let's say it's 3.5 foot-pounds of force. So let's go ahead and look at some FRC motors, and we can look at this motor resource library, go ahead and look at the performance data. So if we open that up, what we see is that the 775, so we got the West Coast Product 775, the RS 775, the AndyMark 775. What we're going to want to look at probably is the BaneBot 775 because it has a really good stall torque. So its stall torque is 111 inch ounces. So 110 inch ounces to foot-pounds, right? That's what we want to know. How close are we to what we want to be? How close are we to 3.5 foot-pounds? So we're at 111. So we're at 0.58 or so foot-pounds. So to even be able to move it at all, this is at the stall current, we'd have to have, almost 10 times the torque. Well, that's sort of easily accomplished by using a 10-to-1 gearing gearbox, which is probably what's hidden right here. Now, in addition, as I'll talk about in a little bit, this chain and sprocket will allow for a little bit more of a ratio as well. I'll explain that in a little bit. But first things first, let's get a motor into our assembly. So what we can do is we can go ahead and let's go to VexPro, and what we want is their Versa planetary gearbox. Now, my understanding is that 254 makes their own gearboxes a lot of times, but it's pretty unlikely we're going to be making our own gearboxes, and in theory what we're trying to do is simulate how might we make something like this. So let's go ahead and go down to the CAD files because that's what we actually care about. And we're looking for a 1/2 inch hex output, and we're looking for an example of a 1-stage gearbox. So we're looking for a 10-to-1 single stage 775 right here. So I'm going to go ahead and click download. It downloads this step file, and I can just go ahead and drag this step file right into SolidWorks. And right now it's sort of importing it. Taking a little while. It's quite a bit of stuff inside of this whole assembly, so it's going to give us a minute before it actually is ready to allow us to edit it. Alright, so here we go. We've got our model here. So we're going to go ahead and we're going to save this because it's going to update some of the stuff when we save. And we're going to save it just as the name that it came with, without that 1 at the end. Alright, we're going to save all the components, so all these components over here are going to get saved along with it. They'll all end up in that folder as well. And then we'll go back to our assembly. And what we're going to go ahead and do is insert this versaplanetary gearbox into our assembly. And we're going to say, all right, well, it looked like it's under here. So let's go ahead and mate those planes, and then the front of this to there. All right, looks good. Okay, so now we have this motor fixed, and what we need to do is think about how to actually use this motor to have this happen. So it's pretty clear from the picture that what they're doing, I don't want to open Outlook, is what they're doing is they're using a sprocket here with chain on it, and that chain's being driven by this motor. But if I were to put hex bearings in here and a hex shaft with a sprocket on it, and to spin that sprocket using this motor, this would never move because a bearing doesn't actually translate motion. So what I'm going to need to do is change this from a circular hole for a bearing to an actual hex hole. So when the hex goes through it and it spins, it moves this. So let's go ahead and do that. We're going to have to open this guy up and edit it. So what I'm going to need to do is delete this second extrusion because that's the one we're going to need to replace. Then I'm going to go ahead and edit this sketch. Go ahead and select it. Hit Control-C to copy it and close the sketch. And then we're going to go ahead and pick this face and start a new sketch. We go ahead and paste our sketch on there, and it's backwards for some reason. So we're going to go and select it all and do a rotate entities. We're going to select one of these points as our center of rotation and rotate 180 degrees. Yeah, that's what we want. Perfect. So now I can pick here, and I want that to be right on this corner right here. Zoom in a little, hit Shift, and say that they are coincident. And now that looks good, but we want to change this hole to a hex. So we'll go ahead and pick hex. We'll go ahead and put the hex in here on that point, make it 90 degrees, and then we'll size the hex to a 1/2 inch. So there to there. Didn't quite get it. There to there. All right, 0.5. All right, we can exit that. Go ahead and extrude it. We're going to extrude 0.25 inches, and we're going to extrude the other way, and I'm going to click OK. And that's looking pretty good. So now what we have is a hex hole. So when we go back to our main part here, I'm going to go ahead and click yes. Oh, we got some problems because some of this stuff is missing now. That's okay, we don't need it really anymore. In fact, this now translates because I was using that concentric to decide where it was. So we're going to have to go ahead and change that. So we'll go ahead and go into these mates, and we'll edit this mate that's broken. So it's missing this face from the 254 collector, and I'm pretty sure that this is for a concentric, so we're going to go ahead and say it's right here, that this is what we're actually missing. And okay, that made that happy. Now this distance is missing as well, and this is our 1 inch distance, so it's missing the face from right here. And click OK, and sure enough, that fixed all of our problems. Now it's happy, and we are separated the way we want to be. And now, if we were to put a hex shaft on here, as I were to rotate the hex shaft, it'll rotate this piece here. Okay, now that we have this hex hole and we're all ready to actually translate the motor rotation into movement of this outer arm, let's go ahead and figure out which pieces we actually need to do that. First of all, we're definitely going to need some hex bearings to put into here. So let's go ahead and find ourselves some of those. So let's get them from, let's see, let's try Vex Pro. We can go bearings. And we want some bearings here. So we want flanged bearings, we want a 1/2 inch hex flange bearing, but we can go down here to their CAD. Alright, so that's a radial bearing, it's not what we want flange bearings, 0.5 inch hex ID here. Go ahead and download that. And we can take that and we can drag it into SolidWorks, and then we'll go ahead and, we don't need to proceed with feature recognition, we'll just go ahead and save this as our long name here, this hex bearing, put it in here. Alright, and now we can go back into our main and we can insert it. Alright, go ahead, grab that, and we can mate there, and then we can decide on, we need this piece now, this inner portion here, to be flush, like that. Go ahead and place that. I'd say that looks pretty good. And we can go ahead and copy this with mates. We want one on the other side too, because that will allow this shaft to be more rigid in the center here. We can repeat that mate and then do coincident mates on this side. And there we go. That looks good. Alright, so now we've got our hex bearings in place, and now we need to place the hex shaft. So we can go ahead and decide, alright, how long do we want this hex shaft to be? For now, we'll just make it the length of the distance between here. So I'm going to measure from there to there. So we'll make the hex shaft 0.234 inches. So let's go ahead and start a new file. New part. Alright, and we'll go ahead and do our sketch. And once again, doing a hex, flip it over, and dimension it 1/2 inch. And exit the sketch and go ahead and extrude it. And we said, what did we say? I do this all the time. Go back, I'm going to exit out of this. I'm going to go check, let me measure this real quick. It was nope, that's wrong, because that's to the outside of the face, not to the outside of the bearing face. Outside the bearing face, 2.34. Alrighty, 2.34. So go to here, extrude it, 2.34. Alright, we can go ahead and save this. And we'll save it as hex shaft for 254 arm rotation. Alright, go back into our main setup here, insert it, hex shaft. Alright, so we know we want one end flush with this, we can mate that, and then we're going to want to flip this because it's pointing the wrong way. There we go. Then we'll do some edges here, so we'll do this guy into there, and we'll do this guy there onto there. Now it's mated nicely into there. We're going to need to mate up everything else as well, but it'll only take one now. So there to there. Okay, good. And then we're going to say this one, its face, now going to mate to that face. Alright, and now if I rotate this shaft, it'll rotate this head thing, because these are now locked in place inside that hex shaft. Now that we have this into place, we're going to want to go ahead and power it using sprockets and chain, just the same way that 254 did. And so we'll go ahead and start with some number 25 sprockets from VexPro, and we're going to want 1/2 inch hex bore here. And so go ahead and download that, and we'll drag it in. No feature recognition, so we can go ahead and just save this as they've named it, and go ahead and insert this into our model. Now we're going to want to put this small sprocket onto the motor itself, because that will allow us to have a higher torque on this arm. This arm is going to have a lot of torque on it, and we'll talk a little bit more about that later. But for right now, we'll go ahead and mate these together and get that face line there. Perfect. And get this face aligned with that one. And all right, there we go. Now we need to put the large sprocket here. And it looks like to me that VexPro doesn't have any especially large sprockets. So we're gonna, they have 1 1/8 bearing bore sprockets that are larger. So something like this, we can take a quick look. So this could work for us, but we're gonna have to do a little bit of work to make it so. So we're gonna download this, do 72 tooth, so nice big sprocket. Processing. So what we're going to need to do is make ourselves an adapter so that we can use that half-inch hex along with this, because right now it's not going to fit that half-inch hex at all. So let's go ahead and make ourselves an adapter. We're going to start by sketching on this so that we can get the dimensions that we want, and then we're going to copy this sketch into a new part. So I'm going to go ahead and basically use the dimensions already defined here. It's not, I don't like that. There we go. I need the center points, and then it'll drag to the external points. That way all my holes will match up perfectly. There we go. There we go. So it's basically grabbing the center points of these and then dragging it out to there. All right, great. So we've got our sketch. We can go ahead and do a center. We're going to be putting a hex in the center here. We can do that right now. We can dimension the center hex. And then what we can do is we can select this whole sketch and copy it. And we'll do a new part. And we'll go ahead and start a new sketch. Paste the sketch in. And we can move these entities to the center point. It's kind of nice to do. There we go. All right, so now we're going to need to actually make our main body portion so that this is all encompassed as well. So we can do something like this. And let's give it a size that seems reasonable. We'll make it 3 inches. All right, we can exit from that. And then we can go ahead and extrude this, and we'll do our 010. Okay, so now we've got this, and we can call this our hex adapter for 72 tooth sprocket. All right, so now we're ready to put everything together. Okay, now that we've got this adapter, it's time to put everything together. We can go ahead and delete this sketch because we're not going to need it anymore. Exit it and delete it. All right, going to the main collector then, we go ahead and add in our sprocket here, and then we can also add in our hex adapters. So we'll add one in first, and we'll end up doing a copy with mates as previously. First we'll mate these faces together, make sure it's the right ones. Yeah, that looks good. Then we'll go ahead and mate up these circles. We only need to mate 2 of them, and then it should work. Back concentric. And then the same with here and there. Make that concentric. All right, and now they're mated together. Let's go ahead and copy with mates. There we go. And we're going to want to repeat the concentrics, but we'll just flip which side it's on and put it over here. All right, and I think we should be all set, except that's clearly wrong. So we'll have to fix that a little bit. Go ahead and delete one of these concentric mates. And then we can rotate this more or less into place. Let's fix this real quick. Fix it. Rotate this where we want it more or less. Where's those holes at? There they are. All right, and now can go ahead and mate these. Shift, mate. Alright, now we're good. Now we can let this float again. Float, and now we can put this sprocket on our actual piece that we want over here. So first we can center it by making it concentric. Go ahead and make that. Alright. And then all we have to do is pick one face here of the hex. Mess that up. Pick here. Mate that with one face of this. There we go. And then the other thing we can do is we can say, alright, we want this to be flush with that. And there we go. Now we've got our really, really big 72 tooth, which might actually be too big, but something like that. And so now we can look at this and say, all right, with it in the down position, I'm going to need to be able to see the top of that. So I need to slide it this way. Now I think the chain will actually make it. So there we go. So that's our little tooth to big tooth setup. So now if we take a look at these sprockets and take a look back at the picture, it kind of looks like the sprocket we put in is probably a little bigger than the actual sprocket size in the picture. And so, you know, we could put in a small one. For now, I'm just going to leave it. One thing to think about that I talked about a little bit is the torque differential between going from a small to a big sprocket. So one of the things you can look at is a sprocket guide. This is actually put out by Rev Robotics. And basically, if you have a small input and a large output, you increase the torque. If you have a large input and a small output, you decrease the torque. And it's actually the ratio of the sprocket gear sizes that decides this. So I have here a 16 tooth and a 72 tooth. So 72 over 16, we're going to have a 4.5 times increase in torque. And I already have a 10-to-1 gear ratio in this motor gearbox. So that means we're going to end up with a total of a 45 times gear ratio from the torque, the original torque from the motor. And that should give us enough torque to actually move this back and forth. Now it will decrease the speed. The higher torque decreases the speed. That's okay. This doesn't have to be super fast, and it really only has to move a half a revolution ever anyway. So it doesn't have to be super fast, but we do need to make sure that we can handle all the torque that goes along with it. All right, now that we've got this actual power transmission more or less handled, let's go ahead and do the free-floating portion on the left side here. Model that as well. So in this case, we can use a cylindrical bearing and cylindrical setup versus having to use the hex bearings the way that we have here. So let's go ahead and get that set up, and what we'll go ahead and do is pick ourselves some bearings here, so we can go ahead and download some cylindrical bearings instead of hex bearings, and go ahead and bring that in. Alright, now we're just going to go ahead and save it. Alright, and then we're going to go ahead and insert into here. Alright, there we go. So we've got 0.5 inch ID flange bearing here. We're going to go ahead, mate to that, and then flip it. We're going to want it like that. And we can then mate this from the outside. So this way, if we mate them from the outside, we'll be able to hold this into place with a retaining ring. I'll go into that in a minute. But first, let's go ahead and copy this with mates and put in 2 more. It's always on the same concentric thing. All we're changing is the face that it is mated to. And it's just that easy. And we're all done. Alright, so now we've got them all in there. Now what we need is to actually hold this stuff into place. And we can go ahead and do that by using retaining rings. And we can really simplify our life by dealing with things like retaining rings instead of having to basically put in nuts and bolts. And it allows us to retain things from both sides as well. So what we're going to need to do is actually model our circular shaft with indentations in it for these rings. So let's take a look at what type of retaining rings we're going to want. So let's go to McMaster, everybody's favorite hardware website, because they have a lot of CAD models and useful stuff like that. And we want retaining rings. All right. So let's go ahead and just take some retaining style and standard rings. We'll do heavy duty because, you know, we're robotics and we're worried about stuff like that. So they're going to be a little thicker, a little wider grooves, but those are sometimes easier to make anyway. So we'll go ahead and take for a 1/2 inch OD, because that is the size that we'll be using. And we can go ahead and look at the product detail. So coming down here, it'll tell us exactly how to make what we want. So with the 1/2 inch shaft diameter, we have a 0.016 groove depth and a groove width of, is it not, there it is, I'm sorry, groove width of 0.056. So let's go ahead and we can now use that information to make our cylindrical shaft. All right, now that we have an idea of what we're going to be using, we can go ahead and we can create a new part and use that information to build our shaft. So we're going to go ahead and be using a rotational extrusion, meaning that we're going to be rotating around this line that I'm making right now. We'll go ahead and make this line, and then we're going to have to go ahead and make ourselves some of these little divots that are where the retaining rings go. I don't know, we don't have to be exact with these because we'll be setting up all of our lengths by constraining these together. So just get them down on paper basically, or on screen. All right, good enough. And we're missing one line here, put that in. There, all right, good. So one of the things that we know is, for instance, that these 4 bottom portions are all going to be collinear. So we'll select these 4, make them collinear. They're also going to be equal. So make them collinear, make them equal. We also know that this top portion of the shaft is all collinear as well. So we'll do that as well. There we go. All right, so now all we have to do is we need to select this groove depth and this groove width. And we can do that by setting the distance from here to here and just setting the distance of one of these because they're all equal. So the groove depth is 0.016, but because we're rotating, we need to divide that in half. So what that means is that this is actually going to be 0.08. So not very deep. And then we know that this width here is going to be whatever this groove width is. So that groove width is 0.056. All right, cool. So there we go. We've got our grooves, and they're all the same, and now we just need to locate them on this shaft. So first what we'll do is make sure that we have a little bit of room in the end here. So let's make sure that we have a 1/16 of an inch sticking out before we hit the first groove. So that means that we'll go ahead and set this length here to 1/16 of an inch. All right, great, and then there's our first one. So then the question is, where should our next groove be? So if we look at here, how far from our first groove to our second groove? Well, it should be just about the distance from here to here, so 0.31. So we'll do 0.315. Give it a little bit of extra length there because we don't want it to be completely tight on the bearing. So we're going to say 0.315. There we go, and then our second one. So now the question is, from that to the next, how far are we going to go? So we're going to go here to there. So we got 0.94. We already took off 0.05, and we're going to take off another 0.05. So we'll make it 0.93. So let's make that 0.93. And that's flush to this, so that's going to be to the other side of it. So we're going to want to say, what's the distance? So it's going to be 0.93 minus the width of this minus 0.056. So it's going to be 0.93 minus 0.056. All right, good, we got that. And then we're going to finally do our last one, which is going to be the distance from here to there. That's 1.13. We'll do 1.135. Go ahead and do that. Right here, 1.135. And then finally, this last piece is going to be another 1/16 of an inch, 0.62. And there we go. Now we've got it. Okay, so now we're almost done defining this. We do need to know the distance here is actually going to be 0.25 because when we rotate it, that'll be that full 1/2 inch. And then let's go ahead and do our extrusion, the revolved boss base. So we're going to go ahead and decide to do this sketch, and we're going to rotate it around this axis of revolution. Click OK. All right, and then what we can go ahead and do is save this and save it as retaining ring left shaft for 254, and then we'll go ahead and insert it in here. And we know that we were wanting this part right here to match up with this edge right here. Go ahead and mate that. And then we also want the concentric mate of these two. There we go. Now we can take a look at it, see if we've done well. Well, this is in the right spot, but that's not. So what's our distance that we're supposed to be here? This distance is supposed to be 0.94, but that, I think what we did was we went from there to there instead of looking at it from this face here to this face here, which is the distance. We actually want 0.88. So let's go ahead and go back and change that. So into this sketch, we'll make this 0.88. Seems wrong because that's going to be too far again. It's 0.88 minus the width, so it's 0.88 minus the 0.056. There. Let's try that. All right, back into here, update it. Now it looks pretty good. Retaining ring holes are where we expect. Let's go ahead and actually download. We can save these as a SolidWorks actually. We'll go ahead and download a SolidWorks file of this part from McMaster. Go ahead and drag that in. And we'll use whatever configuration they set there. All right, cool. We got ourselves a ring in here. Let's go ahead and hide sketches because I don't feel like looking at them in the assembly. Now what we can do is we can take this and we can mate it to this concentrically. And then what we'll do is we'll mate the edge. So we'll say, all right, I'm going to mate this rear edge to this here. And there's one retaining ring. Look at that. Looks great. So let's go ahead and put the other three in. And we can do a copy with mates. And we'll go ahead and say, yep, concentric's always the same. Now I just need to pick our planes. Whoop. So one of them is going here. Good. One of them is going on this end. So I'm trying to pick the same faces. There we go. Looks good. And then one more needs to go right there. Okay, close it up. And now, look at that. We got a nicely set up, freely spinning shaft.